Okay, so here is 4.2. This is page 2 and 3. Again, look at the top. It tells you how I'm going to grade this, what you'll have to be able to do. So on question 13, because this continues from the previous part, it says solve each equation. So x squared equals 14. So I do that by taking the square root of each side. So I know x equals 4, but x also equals negative 4. Now some of you have been writing this as x equals positive or negative 4, and that's fine. 14 is similar. We square root both sides. Remember the square root of 121? Okay, the square root of 121 has both a positive and a negative square root. So we've got m equals 11, because 11 times 11 is 121, and also negative 11. Okay, number 15. It's asking you to solve it. So you could make a table, you could graph it, you could solve it using factoring, you could use the quadratic formula, you could use Poche and Low, you could complete the square. I'm going to see if it will factor, because if it does factor, that makes me really happy. So when I try to factor, I know it has to add to this and multiply to this. And I go, does it multiply to 20 and add to 12? So I go, well, 6 plus 6 is 12, but that only adds up to 12. 7 and 5 makes 35. But 10 and 2 actually does work. So we would have x plus 10 times x plus 2, sorry, you can hear my kids in the background, equals 0. And once you factor, remember that each factor can be set equal to 0 as long as it's set equal to 0 in the end. So x plus 10 equals 0, x plus 2 equals 0, and then you just have to figure out what would make that 0. So x equals negative 10 for this one, and x equals negative 2 for this one. Number 16, I would solve similarly. If you'd like to see a different way, I can do that, but this one does factor. Because negative 8, so this would factor as x minus 4 times x plus 2. But if you would rather do like quadratic formula, you love that, it just still works. You would get the same answer. So we go negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so we can do this, and then we go 4 times 8 is 32. So this would be 2 plus or minus the square root of 36 over 2, which is 2 plus or minus 6 over 2. So 2 plus 6 is 8 over 2, and 2 minus 6 is negative 4 over 2. So we'd get, I don't know, a comma there, we'd get 4 and negative 2. And those are the exact same answers you'd get by factoring. So it doesn't matter which method you use, you will get the same solutions. Okay, this one says, identify whether the given value is a solution to the equation. So here's our solution. It says, does negative 5 work? Yes or no? There are multiple ways of solving this. There are multiple ways of trying this. You could plug negative 5 in and see if it works. You could solve it for yourself and see if you got that answer. For me, the easiest way is to plug negative 5 in for each. So I'd go 2 times negative 5 squared plus negative 5 minus 5 equals 5. So I'm checking this. I'm putting negative 5 in for every x and checking it. And I go negative 5 squared is 25. So 2 times 25 plus negative 5, which is minus 5 equals 5. So I go, okay, that's 50 minus 10 equals 5. And 50 minus 10 is 40. 40 does not equal 5. So nope, this does not work. And I showed my work of plugging it in. You could also learn to solve it yourself. You could have completed the square. You just have to make sure that you subtract this on over. Okay. Solve each quadratic equation, show your work. So on this one I go, ooh, this has got a big old 5 up here. That's really hard to solve. But then I notice that they all divide by 5. Like this divides by 5, this divides by 5, and this divides by 5. So I could start Poche and Low this way. I could start a quadratic formula this way. It doesn't matter. If I divide absolutely everything on this side by 5 and absolutely everything on this side by 5, it's going to have an equal answer. It's just going to make the stretch of that quadratic function a little bit smaller. So I'd have x squared minus 2x plus 3 equals 0. And I look at this and I go, okay, great. But I have a problem right here. It doesn't really factor, because plus 3 is 3 and 1, but they will have to be positive. So it's not going to factor, so I need to find another way of doing it. So I'm going to try either post and lower quadratic formula. I'm going to use quadratic formula, so negative b is positive 2, plus or minus the square root of b squared is 4, minus 4 times a is 1 times c is 3, all over 2a. And a is 1, so 2 times 1 is 2. So I go, okay, well 4 times 1 times 3 is 12. So I've got 2 plus or minus the square root of 4 minus 12 all over 2, which is 2 plus or minus the square root of negative 8 divided by 2. Now, if you can get it this far and say it's not real, I'm okay with that. If you can take it farther, that's actually a level 3. So if you're like, it's not real, so I've got 2 plus or minus the square root of 8 times I over 2, which is equal to 2 plus or minus 2 roots of 2i over 2, and everything divides by 2. So we've got 1 plus or minus the square root of 2 times I. Again, the further you can get that, the closer to a 3 or a 4 you are, but I am fine if you get, oh my gosh, there's a negative in the square root and it is not a real solution. I'm going to have to go into the complex numbers. 19, again, is a little bit tricky because you have this unfortunate 2 over here. So if I divide everything by 2, if I'm going to do post and low, let's say that's my favorite, I divide everything by 2. I've got x squared. 8 divided by 2 is 4. 5 divided by 2 is 5 halves. And that still equals 0. So now I know I'm looking for something that adds up to 4 and multiplies to 5 halves. And I'm like, oh, 2 and 2. So I'm going to use negative 2. So negative 2. Negative 2 minus something. And negative 2 plus that same something better equal up to negative 5 halves. So 2 times 2 is 4 minus u squared equals negative 5 halves. So I know that I need to add 5 halves on both sides and subtract and add u squared on both sides to undo that. So I've got 4 plus 5 halves, which is 13 halves, equals u squared. And I go, square root that on both sides. So the little bit I added was the square root of 13 halves. And so my answer is negative 2 plus or minus the square root of 13 halves. Okay, so it is irrational, it's hideous, but it will work. You would get a similar answer using the quadratic formula. It would look just a little bit different. It would be over 4. Okay, so it does look a little bit different. Number 20 says, can you find the solutions on this graph? And you're like, oh, it's where they cross. So there's one, and there's the other. And then on the next page, it will ask you to find those solutions. Sorry, they were on the same page. So we just have to write the coordinates for both of those. So the first one is over 2 up 1. And the second one is over 5 up 4. So the solutions are where the two cross.